atomic and physical properties of carbon family. First, electronic configuration. Valence shell electronic configuration is ns2, np2. Inner core electrons are also reflected in their properties. Inner core electrons in elements are also reflected in their properties. Okay. So, properties depends upon the electrons present in the inner core. Next, atomic radii. What about atomic radii? Atomic radii increases down the group. Okay, increases down the group, and it increases considerably from carbon to silicon. Thereafter, from silicon to lead, there is only a slight increase in atomic size. Okay, considerable increase from carbon to silicon. Okay, but only a slight increase from silicon to lead. Okay, this is due to the reason that due to the presence of d and f orbitals, that is inner core electrons are present in heavier numbers, so they are poor shielding. So as a result, nuclear charge is more, so there is only a slight increase from silicon to lead. Okay, the slight increase is due to electrons in d and f orbitals. Okay, that is inner core electrons. Okay, they are having poor shielding in the case of heavier elements in the group. Okay, ionization enthalpy. First, ionization energy is higher than group 13 elements or boron family, because these are having higher nuclear charge and size is small compared to group 13. But moving down the group, ionization energy decreases because the size increases. Okay, ionization energy is higher than group 13 because these are having higher nuclear charge and smaller size compared to group 13. Okay, but down the group the size increases, so ionization energy decreases. Okay, and there is a small decrease in ionization energy from silicon to germanium and then to zinc. Only a small decrease. Silicon to germanium, then to tin. There is a slight decrease. Okay, but from tin to lead, there is a slight increase. This is due to the presence of inner core electrons. Okay, that is, the electrons are present in d and f orbitals. These are having poor shielding effect. Okay, this is due to inner core electrons in d and f orbital. So they have poor shielding Okay, so we can see there is a slight increase in ionization energy from tin to lead. So from carbon to silicon there is an increase, then there is a slight, from carbon to silicon there is a decrease in ionization energy, then from silicon to germanium a slight decrease, then to tin also there is a slight decrease, but there is an increase from tin to lead. Okay, there is a slight increase in ionization energy from tin to lead. Okay. Next, oxidation state and valency. Okay, so due to their electronic configuration, the oxidation state is +4. Okay, due to tetravalency. But the heavier elements, that is germanium, tin and lead, these are having +2 oxidation states also. Okay. Now next property is catenation. What is meant by catenation? It is a tendency to link with one another through covalent bonds. Okay, link with one another. To form covalent bonds, that is CC bonds, SI bonds, etc. And it decreases down. This catenation property decreases down, and catenation is more in the case of carbon, then silicon, germanium, tin and lead. So down the group this property decreases. Next is electronegativity. Electronegativity. This, compared to boron family, they are more electronegative. More electronegative than boron family. Okay. Also from silicon to lead, electronegativity is found to be almost the same. Okay. Silicon to lead, electronegativity is found to be same. Okay. Next, physical properties. Physical properties. What about their physical properties? Carbon and silicon are non-metals. Carbon and silicon are non-metals. Then next element is germanium. Germanium is a metalloid. It's a metalloid. Then next elements, tin and lead. They are soft metals. Soft metals, and these elements have high melting point than corresponding boron family. Okay, have high melting points. Than boron family. These are the physical properties.